Hello everyone. In this lesson we're going to cover control flow in Python, including if and else statements, for loops, and while loops. Although Python is a popular tool for data analysis, it is also a general purpose programming language that wasn't designed specifically for data analysis. So it is important to know some basic Python programming constructs that you can use to write custom code and functions to handle situations where built-in functions and libraries fall short. When you run code in Python, each statement is executed in the order in which they appear, and then you can include some logical constructs that let you change the order in which the code executes. And for instance, maybe lets you skip certain statements or run other statements based on what's happening in your code. Programming constructs like these that let you alter the order in which code executes are known as control flow statements. The most basic control flow statement in Python is the if statement. The if statement checks whether some logical expression evaluates to true or false, and then executes a following code block if the expression is true. In Python, an if statement starts with if, followed by a logical expression, and then a colon. And then after the colon, you include whatever code you want to run if the if statement is true. So I'll show a basic example of how to use an if statement below. Here we're going to assign some new variables. X will be 10 and y will be 5. And now we'll write an if statement. If x greater than y, so that's if x is bigger than y, colon, do this. Print this string x is greater than y. And note that anytime you have an if statement in Python, after the colon you have to indent the next line by either 4 spaces or a tab's length. So for this to be proper Python code that will execute, you actually need this space here. If we didn't have that, then the code wouldn't work. But if we have that there and we run this, it is going to do this logical check. And we know that this is true because 10 is bigger than 5. So that means that this will be true and the code below it will execute. So it will execute this and print x is greater than y. Now, if statements are often accompanied by else statements. Else statements allow you to run some other code in the case that the if statement was false. So let's give an example of that below here. We'll set 2 new variables. Y is going to be 25 this time, and x is going to be equal to 10. So since the logical check for our if statement is false, it will actually skip running this code, and it'll go to this else statement, and then execute whatever code is beneath that. So in this case, it's going to execute y is greater than x. And if you want to extend this sort of if-else logical checking sequence, you can include the elif statement to make multiple if checks before you reach a final else. So I'll show how to do that here. We're going to redefine y as 10, which is actually the same value as x. And then we'll first check if x greater than y, do this. Well, it's not because they're the same now. Then we'll say elif, that's saying else if do something. So if that is not true, then we'll say else if this is true, if x is equal to y, print x and y are equal. Well, in this case, that is actually true, so this code block will be executed. But if it wasn't true, it would then go past this to the final else statement. So if all of this was false, then it would run this. But in this case, x and y are equal, so it will stop here at the middle elif statement. So basically, by using if, elif, and else, you can make logical sequences like this of any length you want and do whatever sequence of logical checks you need to get your program to do what you want it to do. Next, we'll learn about for loops. For loops are a programming construct that let you go through each item in a sequence and then perform some operation on each one. For instance, you could use a for loop to go through all the values in a list, tuple, or dictionary, and then check whether those values conform to some logical expression or print the value to the console. So I'll give an example of how you could construct a for loop. First, we're going to make a sequence data structure for us to iterate over using the for loop. So we're going to say my sequence equals a list of this range. We're just making a list of numbers from 0 to 100, counting by 10. You start a for loop using the for statement, and then next you give a nickname to the variable or items you're going to be iterating over. In this case, it's a sequence of numbers, so I'm just going to call this number. And then you write in, and then you put the sequence you're iterating over. In this case, we're iterating over this sequence called my sequence, so that's what we'll write here, and then you put colon, and after the colon comes your code block, which indicates whatever you want to do on each member of the sequence you're iterating over. So basically, this is saying for each number in this data structure, my sequence here, do whatever the code is. In this case, we're going for every number in this sequence, we're going to print the number. So all this is going to do is go over each item in this sequence and then print it to the console in order. So when we run this, we see that it has printed each item of my sequence on a new line in order. So 0, 10, 20, etc. up to 100 counting by 10. So for every iteration of this loop, this value number takes on a different value, namely the next number in this sequence that we passed in. So the first time through the for loop, this number takes the value 0 and then is printed. So a for loop is executed as many times as there are items in the sequence you're iterating over. For a sequence that is fairly small like this one, it doesn't take very long. But if you try to use a for loop to iterate over the sorts of large data sets you might be working with doing data science, that could potentially take a long time. So it's good to be aware that in some cases, using for loops can result in long execution times. Now, in general, a for loop is going to go through every item in the sequence you pass in and run all of the code you have within the for loop, but there are some special operators that let you control the for loop and perhaps let you not go through all the items depending on what you need to do. So I'll go through what a couple of those special keywords for for loops and how they work. So first we're going to show how to use the continue keyword. What continue does is it allows you to skip to the next iteration of a for loop without executing all the rest of the code. So we'll give an example here. We're going to use the same for loop as before. So for a number in my sequence, we're going to do something, but then the inner code here, the inner logic is going to be different. So in this case, we're saying if our number is less than 50, continue. That means after this statement runs, if the number is less than 50, it's going to continue on to the next iteration of the for loop without actually getting to this print number statement. So in this case, it's going to be skipping all the numbers until it gets at least to 50. So when we run this, it's only printing 50 to 100, and it skipped 0, 10, 20, etc. So continue basically lets you skip to the next iteration of the for loop in case you don't actually need to use the value you're currently on and you want to save some computing time. The other special keyword for controlling for loops is the break keyword. What break does is it breaks out of the for loop entirely and halts its execution. So as soon as a break is encountered in a for loop, the for loop exits entirely, and then your program will continue on to whatever code comes after the for loop. So in this case, again, we're saying for a number in my sequence, and now we're saying if the number is greater than 50, break. And that means as soon as this for loop sees a number greater than 50, it's going to exit entirely, and the for loop won't even be running anymore. So let's run this. And here we see the numbers from 0 to 50 printed, and as soon as the numbers in the sequence are bigger than 50, it hits this break statement and exits the for loop. Now you'll notice in this code here with the break statement, we saw a number printed out 6 times, and in the code above, there were also 6 numbers printed. But just because there were 6 numbers printed, that doesn't mean that we did the same number of iterations in the loop, because with continue, we're still going through every item in the sequence. It's just for some of them, after we look at the item and it doesn't meet this logical check, we skip to the next item, but we still had to look at it. With the break statement, you actually exit the for loop entirely and you don't even do the whole rest of the loop. So that means we might not actually look at all the items. In this case, as soon as we saw the number bigger than 50, we broke out. So we didn't look through every single item because after the break happens, we stopped looking at things. So using break statements strategically can potentially allow you to get out of a for loop without doing some additional work you might not have to do. Next, we're going to discuss how to do while loops in Python. While loops are similar to for loops in that they allow you to execute some code over and over again. The main difference is that with for loops, they execute their contents at most the number of iterations equal to the length of the sequence you're looping over. So we specified for something in a sequence, and then the loop does as many iterations as there are items in the sequence. With a while loop, on the other hand, they keep executing their contents as long as some logical expression you supply to the while loop remains true. So essentially, you should be using for loops when there's some operation you want to do a specific number of times and you know how many times you have to do it, such as iterating over each item in a sequence data structure you already have. For while loops, you generally only want to use them when you don't know how many times you're going to have to do something before exiting the loop. So you have to keep doing it until some logical statement becomes true, and then you can stop. So I'll give an example of how to use a while loop in Python below. We're going to set x equal to 5. We're going to create a variable called iters to keep track of how many iterations of the while loop we're doing. This is a pretty common thing to do with while loops because we don't always know how many iterations a while loop is going to run for, so it can be useful to keep track of that. So to make a while loop, you start with the while keyword, while, and then after that you write some logical statement. In this case, we're going to say while our iters variable is less than x, then you put a colon, and after the colon, just like our other constructions, you put whatever code is going to run for each iteration. So for this while loop, we're going to print study to the console, and then after that, we're going to iterate our variable iters by 1. So every iteration of the loop, we're going to add 1 to the iters variable. So the first time through, this will become 1, then the next time through it will become 2, etc. So what this is going to do is print the word study a bunch of times until this iters variable is bigger than x. And then it will exit because when this logical statement is not true anymore, the while loop ends. So when we run this, we see that it prints study several times, but then eventually our variable iters gets larger than x and it exits the loop. Now, while loops can really get you into trouble because they keep executing code until the logical statement you provide is false. If you supply a logical statement that never becomes false and you don't provide some other way to break out of the while loop, it will run forever. For instance, if the while loop above didn't include the statement incrementing the value of iters by 1, the logical statement would have never become false, and then the while loop would have just kept printing study forever. Infinite while loops of this kind are a common problem for programs to crash, so it's important to always provide a way for your while loop to exit. Now, the continue and break statements that we used with for loops also work with while loops. So the break statement in particular provides another way to get out of a while loop, even if the logical statement for the while loop never actually becomes false. So we'll give an example of that here. So we're going to say while true, do something. But this isn't much of a logical check. It's just true. True never becomes false, so that means this while loop will never be false and it will run forever. So let's look at the interior of it. Print study, and then after that, break. Well, it's a good thing that we put this break statement in here because without that, this would just print study forever. But since on the first iteration, it prints study and then does break, which just exits the loop entirely, all this is going to do is print study once and then end. But if we didn't include the break statement here, this would get us into an infinite loop that would crash our Python session. Since while loops have this tendency to expose your program to potentially having infinite loops, it is better to use for loops anytime you're doing iterations a given number of times or iterating over a given data structure, and reserve while loops only for times when you're doing an unknown number of iterations. And you have to be cognizant to always include either a logical check that will become false at some point or a break statement that is going to be reached at some point. Otherwise, you could end up with a program that hangs and crashes. That covers all the base Python control flow statements we're going to learn in this lesson. But we're going to wrap up by going over a special function in the Numpy package that allows you to carry out if-else style logic on sequence data types, which can be quicker than running explicit for loops for that type of thing. And that is the np.where function. So we'll give an example of how you use it below and just talk through how it works. So let's say we had some data in a NumPy array, and we wanted to set values in that data that are less than 0, so negative numbers to 0. Well, we could do that with a for loop, And I'll show how to do that with a for loop here, but we'll also below show how to do that with the np.where function, which is going to do it more efficiently. But since we just learned for loops in this lesson, we'll show how to do it both ways. So first we're going to start just by loading in numpy as we've learned to do. So we're going to import numpy as np. And now we're going to create some data to work with. So this is just creating 25 random numbers between -1 and 1. And now we want to go through and set each number less than 1 to 0. So to do that, we could use a for loop. So here we're going to say for index comma number in enumerate my data. My data is the structure that we just made. So you might notice that this is slightly different than what we did before. Before we just had this for number in and then my sequence. We didn't have the enumerate there or the comma. What this enumerate and the extra comma does is instead of only getting the value for here with number from the sequence, enumerate lets us get both the index and the value at the same time. So that's what this is doing. When we're using enumerate, we're able to say for both the index and the numbers in the data structure. And the reason you do that is sometimes it's useful to have both the index position and the value in hand at the same time. So that's why we're doing that here. So this is saying for each index and number in our data object, we are going to do this. If that number is less than 0, index back into the data at our current index position, which we extracted here, and set it equal to 0. So basically this is doing exactly what we wanted to. It's setting each value that is less than 0 to 0. So we're getting rid of all the negative numbers. And let's just run this and print it to the screen. We can see that we created some new data, and all the values that were negatives are now just zeros. So this for loop construction did work for this, but if we use the np.where function, we can actually do this in a more efficient way. So I'll show how to do that below. We'll do a similar construction for making the data. So we're going to generate 25 new random numbers, but instead of making that for loop, we're just going to reassign my data to this np.where function call. So we're going to start by saying np.where. The first argument to this is a logical test. So in this case, up here, we wanted to test if things are less than 0, do something. So that's the same logical check we need here. If the data is less than 0, do something. Comma, the next argument is the value you want to set if this test is true. In this case, anytime the data was less than 0, we wanted to set the corresponding value to 0. So that's what we're going to pass in here. And then after this comma, the last argument is the value you want to set if the logical check is false. So anytime it's not 0, we just want to set it back to the original value of my data. So we pass that in here. So anytime our logical check is false, it just won't do anything and will return back whatever value was in my data at that position. So when we run this and print it, it results in the exact same outcome as the for loop above, but it was a bit easier, it was a little bit less code, and it's actually substantially faster to do it this way under the hood, because with a for loop, you have to explicitly go through each item one by one in sequence, which can take quite a while for a large data structure, but the Numpy package is implemented in a way such that many of the functions are vectorized, which means instead of having to do operations one by one on sequence data structures, they can actually perform the operation all at once. So it's able to change all of these numbers all at the same time instead of doing them one by one in order, which can save a lot on computing time depending on what kind of operations you're running and how big the data structures you're working with are. So in data analysis and data science in Python, you want to be trying to use NumPy, pandas, and other data science library operations on sequence data types if you can, because they'll generally be more efficient than trying to use explicit for loops using base Python code. So to wrap up, the control flow statements we learned about in this lesson, namely if, else, else if, for, and while loops, those are common to pretty much every computer programming language out there and are the basic building blocks used to create computer programs in all languages. Now, Python and its libraries offer a vast number of functions, but general use functions don't apply in every situation. So sooner or later, you're probably going to need to write your own custom function to perform a task that's unique to your specific project or dataset that you can't just load in from a package like Numpy or Pandas. So in the next lesson, we're going to learn how to package the control flow statements that we learned about in this lesson into reusable functions. If you found this video useful, drop a like, hit subscribe, and I will see you again next time.